Bapak Rifan Masyuri from PT Lautan Luas and also Dr. Jenny Lee as the moderator. Then continued by discussion for 15 minutes and the last one is closing. Ladies and gentlemen, without any further ado, let's start this special event by welcoming speech. The first welcoming speech will be delivered by the representative from STIC CEGIR, Dr. Warma Dewanti. The time is yours.
Thank you very much, Pak Kansa. Assalamualaikum warahmatullahi wabarakatuh. I hope that you can hear my voice clearly. Okay, good morning all. Allow me as a behalf of Science and Technology Innovation Center for Circular Economy and Green Innovation Resources to welcome the Honorable Professor Ji.C. Liu, the Vice President of National Taiwan University of Science and Technology, and also the Director of STIC-CEGIR, and also Honorable Dr. Ajeng Arumsari, Director of Research Funding and Innovation of National Research and Innovation Agency, BRIN of Republic of Indonesia, Honorable Professor Felicia as a Dean of Faculty of Engineering, Widya Mandala Catholic University, and also the Vice Director of STIC-CEGIR, and Honorable all of the distinguished speakers today. We have Ibu Dr. Neni Sinta Wardani, the Senior Researcher in National Research and Innovation Agency. And we also can see Bapak Kasman, MSI, Head of Certification Compliance and Environment of PT Rio Andalan Pulp and Paper, and Bapak Rifat Masyuri SH as a Human Capital and Corporate Affair of Senior Manager of PT Lautan Luas. And also for all of the participants and welcome you all to the webinar, The Role of Green Innovation and Circular Economy in Sustainable Development Goals. And this webinar is a series webinar that held by the Research Center, especially Science and Technology Innovation Center for Circular Economy and Green Innovative Resources. And this Research Center is under the collaboration of National Taiwan University of Science and Technology with Institute Technology 10 November, Widya Mandala Catholic University, and also the National Research Agency. This research center actually has a goal to strengthen the collaboration in research and innovation between Taiwan and Indonesia. And we know that STIC is concerned to encourage and build up the motivation for innovation of science and technology. So that we need all of you as a stakeholder to support us and make the innovation together, especially for circular economy and green innovative resources. And this webinar today actually will be discussed many of green innovation, the implementation of circular economy in the recent in industry, and also the challenge and how it can impact the sustainable development goals. And today, I think we have around more than 90 participants, and that come from many different backgrounds, and hope that all can discuss and share the knowledge regarding circular economy, green innovation, and also sustainability. I'm sure that, and I believe that this webinar will give a positive impact to all of us, and also find a new idea and make the collaboration together to achieve sustainable development goals together. I wish you all have a great webinar. Thank you very much. And I give back to the Master of Ceremony. Wassalamualaikum warahmatullahi wabarakatuh. Thank you.
Thank you, Dr. Warma Dewanti, for the speech. The second speech will be delivered by Dr. Ajeng Arumsari as the Director of BRIN. From Dr. Ajeng, the time is yours.
Okay, thank you. Ladies and gentlemen, good morning. I'm representative from BRIN. I thank you so much and for coming in this event, and we're very happy that we can support for this online webinar, the role of green innovation and circular economy in sustainable development goals. I think it's very important for us to know how the green innovation can support the sustainable development goals, both in the two countries, Indonesia and Taiwan. And I would like to introduce about the BRIN. So we know that BRIN is a special governmental body direct under President of Indonesia, and BRIN is mandated to overcome drastically low critical mass of resources in Indonesia. So we can improve research capacity, and then of course we hope that we can support global engagement and collaboration, so we can speed up knowledge and skill transfer through the research collaboration. And actually, BRIN has the three job and function. First, we try to, as the executive agency for the research and innovation activity. So we have the research organization or the 85 research center that conduct the research, and it can make collaboration with the research center in university or in abroad. And we also have the function as the supporting evidence or the science-based development policy. So we can collaborate with the ministry or agencies and also the local government as the policy support. And last, we have the function as the, how I can say, the funding agency. So in this, we can strengthening the national research and innovation ecosystem as this funding agency. And of course, our directorate under Deputy for Facilitation of the Research and Innovation provide the several schemes for the funding research that can be utilized by the all stakeholders. And we also have the open research infrastructure that can be used not only for the green researcher, but also academic, university, and also the industry and the startup. And we also have the scheme for the research mobility, and we can make the collaboration between the university and overseas, such as with the scheme visiting researcher or the visiting professor. So we can enhance the collaboration here. And for our facilitation about the funding research, that this funding is available for the research activities, and we have the several schemes such as the research and innovation for the Onward Indonesia expedition and exploration, and then innovation product testing grant in health or in agriculture, and also in the in technology. And we also have the scheme for the startup, and the last we also have the scheme for the research collaboration center. So I hope that now the research center, we have the research center for the near waste, and we hope that in the future this research collaboration center will have the collaboration with the university in overseas. So we hope that this research collaboration center, it will become the specific research center that have high standard result, and also that the relevant to the needs science and technology users. So we hope that through this online webinar that we can make more collaboration in the future relating with the green innovation and circular economy in the sustainable development goals. I think that's all. Thank you and good luck for this online webinar today.
Thank you, Dr. Ajeng. Now, we will move to the main agenda, speech from Director of STIC CEGIR and the Vice President of the National Taiwan University of Science and Technology, Professor Jisi Liu, continued by speech from Dr. Rernat Neni Sintawardani from National Research and Innovation Agency. The moderator for this session is Dr. Jenny Lee. from Widya Mandala Catholic University. For the speakers and moderator, the time is yours.
Okay, Cinema Bagi, good morning. Okay, I'd like to, on behalf of our center, like to welcome every participant from Taiwan and from Indonesia. It's a beautiful day in Taipei, and believe it or not, this is a holiday. So I hope the weather in Indonesia is just as good as the one in Taipei. Okay, so I'm going to start my talk on the rare earth elements. Okay. Okay, so good morning. Okay, my talk for this morning will be sustainable utilization of rare earth elements, and I'm JC from Taiwan. Okay, it's been going on for more than 5 years for the China, the United States trade war. As you may see from the title, okay, that was in the early of 2019. According to Forbes, the trade war is going to drag on for a long time. Okay, and also because of this trade war, people started to know rare earth, and the common question is how rare earth could become crucial in the China-United States trade war. And people started to ask, what are rare earth elements? What are they? Okay, why are they so important? Okay.
Awal tahun ada perusahaan yang seniatnya untuk bikin Renstra di Rampinawan tahun setiap tahun ada meeting.
So even just next to Indonesia, we know that some of the industry are producing rare earth elements actually are booming, like the one in Linus in Malaysia. Okay, so briefly, I'd like to define rare earth elements that stand for 15 lanthanide elements, starting from atomic number 57, lanthanum, cerium, all the way to Yb, plus 2 extra. One is the one at atomic number 21, scandium, and 39, yttrium. Okay? And they are important. For example, from this figure, we notice that cell phone made by the United States company, iPhone, or the one made by China, Xiaomi. Okay? You can notice that this picture actually hints that cell phone is cannot be made without rare earth elements. This is a photo that I took last year in western coast of Taiwan. You see the offshore wind turbines along the western coast of Taiwan. This is one of the very ambitious policies promoted by our President Tsai. By year 2025, 20% of the total energy supplied in Taiwan will be from renewable energy. And you may see from the title, rare earth elements, they are the goal of the 21st century, because even short offshore windmill, wind turbine, need rare earth elements to manufacture. And I believe this photo is familiar to every participant from Indonesia. This is an e-scooter made and designed by ITS. Okay, it's called GESITE or GES ITS. Okay, and this is something our friends in ITS should be very much proud of. And believe it or not, in a typical GES ITS, you also need rare earth elements to make. Okay, that's why people say rare earth elements stand for the gold, or they are the gold of the 21st century. Are they really the gold of the 21st century? Maybe, maybe not. But this is the term that I prefer. Okay, to me, rare earth elements are the vitamins of modern day high tech. Just take a look at this figure. We notice that television, monitors, scanners, all the electrical and electronic industries, they near REES. Okay, and if you need to make some medical examination, you also need MRI, cancer equipment, anything. they also need rare earth elements to make. Okay? Laser, polishing powders, wind turbines, microbial fuel cell, green automotives, almost everything require rare earth elements to make. Why is that? It's because of the very unique properties of rare earth elements, like they make them essential for all the high techs. Okay, so from Forbes, published just last month, the title, the article deals with the future battle of the trade war, and according to the article, we know that China nearly monopolizes RE productions. For example, EU imports 98% of the RE from China, and United States imports 78% of its RE from China. Okay, and now whenever we read Western media, we know that the West, particularly EU, is trying hard to decouple itself from the Russian energy, mainly the natural gas. Okay, and somehow people tend to neglect that the Western world actually overwhelmingly rely on China for the IEE supply. Okay, that's why people, politicians, researchers, and particularly geostrategists, they are very much concerned about the thought that China somehow dictates the energy, green energy architecture of the future. Okay, if you take a look at this, the figure, okay, published by United States Department of Energy, okay, we notice that in terms of the importance to green energy and in terms of the supply risk, people come to realize that DY, ND, EU, Y, and terbium, they stand for critical elements that are experiencing supply risk, and they are so important to the development of green energy. And when it comes to lithium, tellurium, nickel, or samarium, maybe they are not that critical when it comes to supply risk. Okay? And that is why every year the Federal Agency of United States Geological Survey, they publish reports. For example, this one is the future of rare earth elements. Will these high-tech industry elements continue in short supply? Will they or will they not? And that's why people are shifting our focus on the potential secondary sources for IEE. What does it mean, secondary sources? For example, the key word, of course, is the domestic sources, to see if somehow we could decouple our reliance on IEE from China or from some other countries. That is to say that let's look for some domestic sources, particularly waste streams, for potential IEE sources. Okay, and that is why people are now adopting sustainability strategies. For example, urban mining, for example, industrial symbiosis, and of course, circular economy. They stand for possible avenues to realize and to substantiate new supplies of critical metals, namely REE. Okay? And according to some of the analysis, the quantities of IEE contained in secondary sources actually could meet the current global demand, even under the premise that only very low extraction yield can be achieved using modern day technology. Okay, so for example, e-waste, the end-of-life electrical and electronic devices, okay, ranging from monitor, from washing machine, refrigerator, fluorescence bulb, PC, cell phone, and everything. E-waste actually has attracted much attention when it comes to developing IEs from secondary waste. And just take a look at this. This figure was published by World Economic Forum back in 2019. Okay, so for example, e-waste actually stands for one of the most rapidly increasing stream of waste. In 2021, total of 52 million tons of e-waste were produced, and it is estimated that by year 2050, total of 120 million tons of e-waste will be produced. Okay. And according to the analysis of a research group, okay, judging from the average IE content in the industrial byproduct or in the e-waste, and judging from the annual global production of certain type of industrial byproduct or waste, people have pinpointed some potential or promising secondary sources. For example, spent nickel metal hydride batteries, phosphor gypsum, as well as fly ash, bottom ash, and bauxite. And in our lab, actually, we are extremely lucky to be involved in applying some novel extraction methods for extracting IEEs from various types of waste. For example, in one of our research, okay, we successfully utilize subcritical water. What does it mean, subcritical water? That stands for water under high temperature and high pressure. Normally, temperature higher than 100 degrees C and pressure higher than 10 bar. Okay? And by using subcritical water extraction, we could effectively and efficiently extract IEEs from spent nickel metal hydride batteries and successfully converted them to precipitates. Okay. Also, just very recently, thanks to the help from ITS, we obtained phosphor gypsum from Petrokimia Gresik, Indonesia, and then we apply microwave-assisted leaching for the recovery of IEEs, including yttrium, lanthanum, neodymium, as well as phosphorus from PG. Okay? And we also apply the above mentioned two methods to extract IE from waste CRT phosphor. Okay? And we published some papers for your reference. And to summarize our studies, we have demonstrated that both subcritical water extraction and microwave assisted extraction had leaching efficiency almost 100%, okay, using low strength hydrochloric acid, normally 0.5 norm, no higher than 1 norm concentration. And the reaction time usually is very short. It could be as short as less than 5 minutes. Okay, and according to some of our preliminary assessments, actually both extraction methods are very energy efficient, meaning that developing novel methods like this could be green and sustainable processes that could fit the future development for technologies for realizing circular economy, especially when we denote rare earth elements. Okay, and actually different from Indonesia, which is rich in terms of natural resources. Taiwan is short on space, and we don't produce nickel, we don't produce oil, we don't produce natural gas. That's why people in Taiwan have embraced recycling for 3 or 4 decades. Okay, and actually Taiwan has benefited and seen a boom when it comes to recycling. Okay, so for example, maybe contrary to our impression, okay, young professional entrepreneurs are engaged in recycling industries like this handsome young people, a general manager of a typical startup company engaged in e-waste management. Okay. So, for example, recycling has become huge, all because of electronic firms, as we know that Taiwan is big when it comes to semiconductor or electronic devices manufacturing. Okay, so that's why we see the growth from 100 recycling outlets to over 2,000 in a very short period of time. Okay. And just to sum up, not just in Taiwan, actually last year, people all over the world enjoy watching and following Tokyo Olympic. And maybe you know, maybe you don't, like all the medals, gold, silver, and bronze delivered in Tokyo Olympic actually are 100% from e-waste. And people think this is a very good example when it comes to sustainability. So I like to sum up my talk, okay? But the first thing I like to remind everyone is that to fulfill sustainable utilization of rare earth elements, research and development for technology is only one part of the overall required units. For example, we also need politicians to engage in policy revision. We need people in the central government to come up with some incentive policy that provides tax incentive so that private sectors will be engaged happily. We also need to set up and establish strategic partnership, national or international, like our center, so that brilliant ideas can be exchanged. We also need to stockpile IEEs, okay? And all these are essential ingredients to set up a good domestic IE supply chain. Okay? So just for your information, okay, the one that people in ITS, in BRIN, and in William Mandala are engaged are only focusing on recycling of R&D scale. But let's hope that somehow the technology that we develop or we research at a lab scale level can somehow be scaled up and successfully be applied at industrial scale, so that somehow the IE can be utilized in a very sustainable manner. So this is my talk. Thank you very much. Terima kasih. Thank you.
Okay, thank you very much for the very nice presentation, Professor. And okay, to all participants, please keep your question for Professor Liu first, since we have to go to the next presentation before Q&A section. Okay, so the following distinguished speaker is Dr. Neni Sintawardani. Let me introduce her a little bit. She is a senior researcher in the National Research and Innovation Agency, or BRIN, and she's a role model for all ready researchers. She received the Underwriters Laboratories Asian US Science Prize for Women 2021. Please welcome Dr. Neni. The time is yours.
Thank you. Good morning, everybody. Assalamualaikum warahmatullahi wabarakatuh. And please allow me to speak in Bahasa Indonesia, because I prepared everything in Bahasa. So, Professor Liu, I think that you can have a translation from Dr. Jenny. Di sini saya ingin berbicara mengenai limbah tahu. Jadi tampak sederhana, limbah tahu sebagai sumber bahan baku baru untuk menunjang ekonomi berkelanjutan. Sebenarnya pertanyaannya masih terbuka, mungkinkah itu? Lanjut. Ya, di sini kita berbicara hal yang diakui oleh dunia, yang tadinya dianggap sebagai isu, tapi sudah diakui memang ini terjadi dan mempengaruhi segalanya, yaitu peningkatan jumlah penduduk. Ini tidak bisa direm tampaknya ya. Jadi terkait juga dengan kebutuhan global pangan dan barang lain tentu meningkat. Penggunaan sumber daya alam itu juga tidak pernah bisa direm sedemikian rupa karena tetap ada eksploitasi yang besar karena kebutuhannya besar. Jadi di sini juga kita melihat salah satu hal yang paling krusial untuk manusia adalah kebutuhan air. Jadi kebutuhan air dunia naik sesuai dengan tingkat kemakmuran. Makin makmur orang memakai air dan jumlah yang melebihi daripada orang yang tidak cukup makmur. Dan ini hal yang sangat ironis. Tapi ketersediaan air dunia itu tidak meningkat, tidak berubah sebetulnya. Jadi ini ada kebutuhan yang mendesak untuk diatasi. Pendapatan yang tidak adil. Nah ini menjomplangnya ekonomi global. Jadi ada yang makin kaya, tapi juga banyak yang makin miskin. Jadi apakah kita Indonesia akan memilih menjadi negara maju? Apakah itu memungkinkan dengan tantangan yang ada? Nah ini satu ironi, kita lihat saja terkait dengan nikel kita. Kenapa ada larangan ekspor bahan mentah biji nikel? Karena ternyata eksploitasi kita besar-besaran merusak lingkungan sedemikian rupa yang kita peroleh sedikit. Sedangkan negara lain, banyak negara maju, juga Cina adalah mengimpor nikel itu dalam bentuk biji dan kemudian memperoleh pendapatan jauh lebih besar untuk mendapatkan nikel untuk keperluan yang lain. Ya, jadi ini ada kesenjangan pendapatan. Itu tantangannya dari laporan SDGs Indonesia dari Bappenas tahun 2020. Itu dilaporkan bahwa Indonesia menghasilkan limbah per tahun sekitar 68 juta ton. Itu keseluruhan limbah. Jadi limbah dari berbagai industri. 5 kelompok industri utama sebetulnya yang ada di situ, antara lain industri pangan. Tetapi industri pangan itu kalau dilihat hanya sedikit emisinya dibandingkan dengan industri lainnya. Nah, emisi karbon di Indonesia yang selalu mengatakan Indonesia itu besar emisi karbonnya 618 juta ton. Itu ternyata cuma 1,7% dari emisi global. Sedangkan di tahun 2019 itu sudah ada penurunan. Di tahun 2020 itu turun 7,5%. Jadi upaya Indonesia cukup signifikan sebetulnya. Dampak dari semua isu tadi sebenarnya ada perubahan iklim dan penurunan kualitas lingkungan. Baik, lanjut. Nah, bagaimana upaya mengatasinya? Kita semua tahu upaya mengatasinya kita harus efisien dan efektif dalam penggunaan sumber daya alam. Bagaimana? Nah, kita mengurangi eksploitasi sumber daya alam, apakah itu tidak malah merugikan kita atau malah menguntungkan? Sebagian negara maju itu menyimpan sumber daya alamnya sebagian rupa. Dia beli dari yang lain karena dia mempunyai uang. Nah, kita apakah kita mampu? Mengurangi konsumsi sumber daya alam, di lain pihak kita ingin tetap meningkatkan kemakmuran. Hal yang lain adalah mengubah kebiasaan, apakah itu mudah. Nah, pengembangan proses teknologi nirlimbah atau zero waste green technology biasanya, ini biasanya ditujukan untuk memperoleh bahan baku baru dari limbah atau dari side product yang tidak dimanfaatkan sebelumnya. Dan juga terutama adalah memperoleh energi yang bisa dimanfaatkan kembali. Nah, implementasi dari circular economy adalah untuk meminimalkan limbah dan memaksimalkan sumber daya. Ini tantangannya, limbahnya minim, digunakan kembali, dan sumber daya yang ada semua dimaksimalkan sedemikian rupa. Hal ini akan mengurangi beban lingkungan akibat penggunaan sumber daya yang tidak bijak dan juga diharapkan tidak ada lagi pemborosan energi. Ada yang menarik dari studi Bappenas tahun 2021, jika Indonesia mengadopsi secara menyeluruh prinsip zero waste circular economy, maka pertumbuhan ekonomi Indonesia akan tumbuh 45 miliar dolar. Ini jumlah yang sangat tinggi sebetulnya. Ya. Nah, sektor pangan sebagai satu dari 5 sektor industri yang besar, yang terpenting, itu bisa mengurangi limbahnya sampai 50%. Nah, ini bisa mengurangi 59 juta ton emisi karbon per tahun dan menghemat air 4 miliar meter kubik. Nah, di sini yang menarik sebenarnya jumlah air yang bisa dihemat. Kalau dari emisi karbon ya ternyata juga industri pangan ini kecil sekali dibandingkan dengan tadi 600 sekian emisi kita. Jadi ini sebenarnya kecil. Nah, upaya dari satu sektor yang kecil ini tapi menyangkut hajat hidup orang banyak, karena pangan itu menyangkut hidup manusianya, itu menjamin keberlanjutan lingkungan. Lanjut. Mohon dilanjut. Oke. Nah, sekarang kita masuk ke tahu. Semoga semua sudah tahu mengenai tahu ya. Ini tahu sebagai sumber protein dan makanan yang murah meriah. Di mana-mana saya setiap hari harus ada tahu ya. Di mana-mana kita bisa menemukan tahu. Nah, ternyata konsumsi tahu bagi penduduk Indonesia itu berbeda-beda antar provinsi. Rata-rata 8,1 kg per orang per tahun. Data BPS tahun 2019. Jawa Barat itu konsumsinya termasuk yang terbesar dengan Jakarta. Jadi Jawa Barat dan Jakarta itu konsumsinya besar, di atas 9 kg per orang per tahun. Nah sekarang kalau dengan tingkat populasi yang sekitar 60% dari total penduduk Indonesia, ini Pulau Jawa membutuhkan perhatian sangat besar terkait keberadaan bahan bakunya. Berapa banyak konsumsi kedelai untuk tahu? Dan bisa dikatakan hampir 80% kedelai itu impor. Amerika adalah sumber kedelai yang terbesar, ya. Jadi kita masih impor karena bahan baku kedelai lokal tidak bisa memenuhi. Nah ini di Jawa akan mengambil dengan perkiraan itu adalah sekitar 60% tentunya. Nah konsumsi air bersih untuk pembuatan tahu apakah mencukupi? Karena untuk membuat tahu itu membutuhkan air dalam jumlah yang sangat besar. Konsumsi energi untuk pembuatan tahu juga bagaimana? Sebagian industri tahu adalah industri kecil, sebagian besar. Mereka menggunakan sumber energi yang diusahakan semurah mungkin. Di beberapa kota besar, walaupun itu industri kecil, mereka biasanya menggunakan LPG, tetapi yang LPG bersubsidi, bukan LPG biasa, bukan industri. Nah, yang sebagian lain masih menggunakan biomasa dari kayu, dari sekam dan lain-lain. Nah, di balik semua kebutuhan bahan baku itu akan menimbulkan juga limbah. Nah, di industri tahu ada limbah padat dan ada limbah cair. Ini memerlukan perhatian. Harus diingat bahwa sebagian besar pengrajin tahu itu skalanya mikro dan kecil. Jadi 5-19 pekerja. Nah, dari Kemenristek tahun 2010 dan itu masih valid sampai saat ini rasanya, belum ada data terbaru. Itu ada 84.000 pengrajin tahu skala kecil mikro. Nah itu menghabiskan 2,56 juta ton kedelai per tahun. Nah satu ironi lagi yang harus kita hadapi adalah bahwa struktur bisnis di Indonesia itu 99% didominasi oleh industri skala mikro kecil menengah yang melibatkan 95% tenaga kerja. Tapi kontribusi terhadap GDP itu hanya dekat-dekat 50% dari GDP Indonesia. Jadi kalau tadi kita Profesor bicara mengenai rare earth, itu industri yang sangat besar dari modal dan juga dari penghasilan sebetulnya. Tapi ini industri yang kita pangan hanya 56%. Lanjut. Bisa dilanjut? Oke. Nah, kita tahu dari produksi tahu, kalau ini kita mengambil dari, kami sudah membuat satu
Bu Neni?
Yeah, maybe the internet connection of Bu Neni has a problem now. Halo? Halo, Bu Neni? So, okay, while we are waiting for Dr. Neni, so let me try to translate the presentation of Dr. Neni first.
Okay, everybody, hi.
Okay.
Can you? Okay.
Okay.
Okay,
Okay, welcome back, Bu Neni. Please
sorry.
continue. your
So I have
presentation.
to use my colleague's laptop. Oke, sekarang kita melihat satu mass balance dari pembuatan tahu ini. Ternyata dari 1 ton tahu itu akan menghasilkan 4 ton, akan menghasilkan 4 ton 4 ton tahu. Tapi membutuhkan air bersih yang jumlahnya bervariasi 5 sampai 25 meter kubik yang akan berakhir menjadi limbah. Oke. Ini saya sorry, I have to have a full screen. Okay. So, ya, saya ingin memperlihatkan bahwa betapa besarnya jumlah limbah yang akan dihasilkan dari satu proses pembuatan tahu. 1 ton itu akan menghasilkan limbah yang kita sebut limbah air encer itu mungkin hanya 1 sampai 12 meter kubik. Itu variasinya memang besar karena tergantung pada pembuatan, pada cara. Nah, kita bisa melihat bahwa sebagian besar industri tahu di Indonesia adalah industri rakyat, di mana kita bisa melihat di grafik yang di samping itu bahwa mereka bekerja 24 jam. Nah, bisa dilihat di situ fluktuasi air limbah yang dihasilkan. Yang kita harus perhatikan ada air limbah yang pekat, yaitu yang di bawah itu, yang kalau di situ saya mengambil studi di Giriharja itu sekitar 2,5 sampai 2 meter kubik. Kita lihat di situ per jamnya. Nah, itu pH-nya itu antara 4 sampai 5. Jadi asam dan temperaturnya tinggi. Nah, ini membutuhkan solusi teknologi yang harus kita pertimbangkan terkait dengan 2 hal di atas. Nah, sedangkan limbah yang berupa padatan atau kita sebut onggok itu sampai saat ini selalu diambil oleh para peternak sapi. Jadi masih tidak bermasalah walaupun hanya bisa di dalam skala yang jarak tempuh yang dekat, karena begitu dibawa terlalu jauh dia akan menimbulkan bau yang bukan main, cepat sekali terfermentasi. Bisa dilanjut? Nah, ini kita bisa melihat 2 contoh di kiri dan di kanan. Itu yang dot kuning adalah lokasi dari pabrik-pabrik atau dari pengrajin-pengrajin tahu. Yang di kiri adalah di satu desa di Sumedang, sedangkan yang di kanan ada di Kota Bandung. Nah, yang di Kota Bandung kita bisa melihat itu hanya dengan area 200 kali 200 meter. Itu ada 19 pengrajin tahu dan semua mengalirkan melalui kanal atau got-got yang ada, mengalirkan limbahnya ke situ. Jadi bisa Anda bayangkan betapa konsentrasi limbah itu terjadi di kawasan yang padat penduduk. Sedangkan kalau yang di perdesaan, yang di kiri itu cukup tersebar, tetapi dia luas, lebih luas. Nah, bisa melihat di situ yang lingkaran biru yang di kiri itu adalah batas dari masyarakat yang menerima advantage dari biogas yang dihasilkan dari pengolahan limbah itu. Kita bisa lanjut. Mohon lanjut. Bisa dilanjut? Oke. Nah, sekarang kita mengenai konsep 5R yang diharapkan dari circular economy. Kita bisa melihat sekarang dari limbah cair. Limbah cair pekat dari produksi tahu atau yang kita sebut W itu COD-nya bervariasi dari 7 sampai 14 sebentar, kembali ke sebelumnya. Bisa kembali ke sebelumnya, kita bisa melihat bahwa halo? Ya, nggak bisa dengar? Sorry. Nah, setelah itu, satu lagi. Oke, coba ke ini, lanjut. 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 Ya, Nah, di sini kita bisa melihat betapa konsentrasi W itu masih mengandung COD yang cukup besar. Oke, ini terlalu cepat. Terlalu cepat, masih mundur. Ya, saya akan menggambarkan saja bahwa W dari limbah tahu itu mengandung konsentrasi COD yang cukup besar, antara 7 sampai masih sebetulnya ini sudah terlalu ke depannya. Jadi jadi mengandung konsentrasi COD yang cukup tinggi, 7 sampai 4 gram per liter, itu membutuhkan penanganan yang baik. Kemudian pH-nya adalah pH yang asam. Nah, jumlahnya itu cukup besar, tergantung pada produksinya tentu. Tetapi jumlah air yang digunakan besar, jumlah air limbah yang dihasilkan cukup besar. Nah, kita bisa melihat kalau di sini dari kandungan protein, ternyata W itu mengandung protein yang juga masih cukup menguntungkan. Tapi kalau dilihat dari limbah yang lain, ada untuk limbah yang padat atau onggok, itu ternyata hampir mirip dengan soy meal. Jadi itu ada beberapa potensi yang harus kita pikirkan sebagai engineer atau peneliti, bahwa apa yang bisa kita lakukan dengan potensi yang ada, teknologi apa. Nah, untuk W di Sumedang itu kita bisa melihat bahwa COD-nya sekitar 7,6 dan masih mempunyai nutrisi, yaitu N dan P yang cukup besar. Nah, itu juga satu peluang. Baik, kita lanjut. Slide selanjutnya. Nah, salah satu yang kalau kita melihat dari COD sebagai engineer, itu kita akan berbicara, teknologi apa yang paling mudah. Nah, dengan tingginya nilai COD di atas 5.000 mg per liter, maka teknologi anaerobik adalah yang paling mudah dan paling potensial untuk dipakai. Nah, kita bisa melihat di Indonesia sudah dilakukan beberapa penerapan teknologi proses anaerobik untuk pengelolaan limbah cair dari tahu, dan ternyata waktu tinggal masih cukup lama, rata-rata di atas 4 hari, dengan efisiensi degradasi COD yang 70% kira-kira. Nah, kami ini satu studi kasus yang kami terapkan di Raharja Sumedang, itu dari pH masukan sekitar 5, itu keluaran bisa di atas 7. Dan ini adalah satu hal yang menarik dari jenis W ini. W ini sangat mudah terdegradasi dan mempunyai buffering capacity yang baik sekali. Sehingga kita tidak memerlukan netralisasi dalam prosesnya. Jadi dengan sendirinya proses anaerobik akan meningkatkan nilai pH karena dia terbuffer dengan sendirinya. Ya. Tapi di limbahnya setelah proses anaerobik, walaupun COD-nya terurai menjadi biogas yang bisa dimanfaatkan oleh masyarakat, ternyata nutrisi N dan P masih tetap ada. Nah, ini adalah satu potensi juga yang harus dipikirkan. Harus bagaimana lagi kalau itu langsung dimanfaatkan atau langsung dibuang, itu juga belum layak. Jadi ya bagaimana? Lanjut, slide selanjutnya. Baik, slide selanjutnya. Oke, nah ini reaktor anaerobik berkinerja tinggi itu sudah kita lakukan, dan beberapa potensi yang kita harus pikirkan adalah bagaimana kita bisa mengekstrak protein dari limbah cair tahu. Nah, ini juga beberapa pemikiran yang saya kemukakan, bahwa dari kedelai itu 71% jadi tahu, tapi masih ada onggok, masih ada W tadi. Nah, onggok bisa untuk pakan ternak, tetapi juga ternyata bisa digunakan untuk dengan valorisasi ekstraksi basa atau yang lainnya, itu masih bisa dimanfaatkan. Nah, sedangkan yang W itu masih mengandung asam amino esensial, itu bisa juga dikembangkan selain untuk anaerobik, setelah itu untuk apa? Nah, itu masih bisa dikembangkan lagi misalnya untuk mikroalga dan sebagainya, sehingga menghasilkan produk yang lain. Lanjut. Ya, bioselulose karena W itu pH-nya rendah dan masih mengandung begitu banyak asam amino, maka kemungkinan menggunakan itu untuk bioselulose seperti nata. Ya, ini mempunyai potensi yang besar karena nata de coco itu bisa digunakan sebagai membran dari audio. Jadi sudah ada patennya di Jepang memakai nata de coco dari Indonesia waktu itu, dan kita bisa menggunakan untuk berbagai hal yang lainnya, antara lain juga untuk selulus murni dan sebagainya. Nah, ini memerlukan teknologi tersendiri. Yang harus kita pikirkan adalah teknologinya adalah prosesnya kalau bisa ya harus continuous, jangan lagi batch, agar ruangan dan sebagainya juga bisa berkurang. Nah, ini bagaimana antara keluaran W dan juga tekniknya. Nah, ini kita buka ini sebagai tantangan teknologi. Lanjut. Saya minta waktu tambahan 1-2 menit. Ya. Ini mikroalga tentu semua udah tahu. Jadi ini adalah sumber untuk farmasi, bisa juga untuk pangan, bisa juga untuk energi biosolar. Lanjut. Nah, ini adalah yang paling kita yang dapat kita rangkum dari semuanya adalah bahwa semua limbah dari proses tahu ini harusnya bisa kembali digunakan dan kembali ke pabrik atau kembali, dipergunakan oleh masyarakat dengan harga jual yang berbeda. Jadi kita bisa melihat di sini beberapa alur yang W masuk anaerobik, dari anaerobik akhirnya masuk ke agriculture waste bisa dipergunakan, tapi biogasnya bisa dipergunakan untuk yang lain. Dan karena airnya masih ada nutrisinya bisa kita pakai untuk mikroalgae misalnya, atau langsung ke constructed wetland dan sebagainya. Nah, ini adalah teknologi-teknologi yang masih terbuka saat ini yang bisa kita coba lakukan. Lanjut. Oke, jadi kesimpulannya adalah bagaimana kita bisa merecycle semua limbah yang ada sehingga itu menjadi produk yang berharga. Jadi potensi yang lain adalah potensi penggunaan air kembali dan juga energi. Nah, kita dengan prinsip pengelolaan closed loop seperti itu, maka bisa memenuhi 3 target SDGs, yaitu clean water and sanitation, affordable and clean energy, dan responsible consumption and production. Jadi dari hal teknis sampai dengan perubahan perilaku, seharusnya itu bisa terjadi. Demikian, terima kasih. Assalamualaikum warahmatullahi wabarakatuh.
Nice presentation. Dr. Neni, ini the presentation. We talk about use behavior of tofu for so many products, and already the scale industry of tofu and the tofu, and the height of tofu in Indonesia is 8.1 kilograms per year, ya Bu ya. So, for Taiwan as well, we eat tofu, and yeah.
So sorry, Bu Jenny. Your voice is cracking.
Okay.
Okay, sorry. What about now? Okay, let me translate it again. Okay, so basically, Dr. Neni has explained the utilization of tofu waste for many products such as microalgae, biogas production, also for the animal feed. I think Dr. Neni and team has already helped many in micro scale industry of tofu in Sumedang to help them to treat the tofu waste for the more valuable products in the Sumedang, I think. And I think that's all for the translation. Okay, for the Q&A, let me open the Q&A section now. So, is there any question from the participants? Okay, you may ask directly to Professor Liu and Dr. Neni, or you can just put the question in the chat column. Okay. So maybe while we are waiting for the question from the audience, so maybe let me start to ask the Professor Liu first. So because Professor Liu has already present how the REE supply chain and REE circular economy is very important in the world right now. So Professor, how Taiwan participate in the circular economy of the REE? And as we know that China monopolized the REE supply in the world very much. So will it be a challenge or the opportunity of Taiwan itself?
Thank you very much, Jenny, for your interesting question. Let me put it this way. For a long time, businessmen in Taiwan have been very keen when it comes to recycle and reuse of all sorts of waste. And now I would say that many big industries, big groups are already focusing on keeping the sustainable supply of REEs. So as far as I know, there are some companies working on this, but how successful are the supply chain? This is something I'm not sure about. But of course, Taiwan is right at the forefront between China and the United States. So yes, we feel very imminent and very clear about the risks. Okay, yeah, thank you.
Okay, thank you very much, Professor, for nice and great knowledge about the development of the REE recovery in Taiwan. Okay. So is there any question for Dr. Neni and Professor Liu again? Okay. If not, maybe let me go to the Dr. Neni. So how is the development of the utilization of the tofu waste so far, Professor Dr. Neni, in Sumedang? Because I know that BRIN, especially Dr. Neni's team, is focusing in Sumedang right now to utilize the waste, the tofu waste in Sumedang. I mean, what kind of product that you already have and you already produce from the tofu waste, Doctor?
Thank you.
Also, sama sistem.
Oh, okay. Some noise. Yes, in Sumedang itself, so our concentration, actually the most important is how to treat the wastewater to be unharmed waste, not waste, unharmed water, so that they can discharge it to the river. And then for the society, it is not very interesting. The most interesting one, hey, what will we get? So, and then using the anaerobic process, of course, it will produce biogas. And the biogas is, the amount of biogas producing daily is enough to be used by the households for cooking, for the daily cooking process. So it's the first years of the plan. There were about 90 households who used the biogas. And then the other effect that we didn't calculate before is the social effect. How the people, of course, they will to use it, but how they want to keep everything. So that's different things. And then when they have to pay a monthly about only 20,000 rupiah for managing the biogas, because the biogas will be distributed directly to the household using the piping. So it's not, so they will not very shocked to change from the LPGs to biogas. Yeah, but now it's only 50% who want to pay. So that's why the management of the plan now just distribute only to the 50% of the consumers, and it works very well. They can use 24 hours per day, but actually from the treated water itself, we still have a problem. The treated water still have COD about 400 milligram per liter. So it's not good actually when we discharge it directly to the river. So it must be treated again, but it's not using the anaerobic, because the anaerobics already can treat the waste 90%. This is huge performance actually, but 10%, it must be treated. So one, the possibility is using for microalgae. This is the bad things. And when we can implement technology continuous, because water is continuously, every day there's water, and we could not collect it because we'll need huge ponds. That's why the challenge is how to make to use microalgae simultaneously, and we can harvest it continuously too. So that's a technology that we need. So Professor told you, it is open to cooperate with you all, and of course with Vidya Mandala. How can we make it? Okay. It's simple actually. It must be simple. The technology is the knowledge is there, but the technology is different. So yes, it's open for
sure. Thank you very much, Dr. Nani.
You're welcome.
Okay, so we got the questions from Yuma from ITS. So I want to ask to Professor Liu, as far as I know, the REE is toxic. Can we directly process the REE? And does it need the certain permissions? Professor, please.
To my understanding, REE actually are not as toxic as the traditional heavy metals, including lead, zinc, cadmium, or copper. Okay, so as far as I know, there's no the so-called effluent standard as applied for IEEs. Okay, so and perhaps also because they are valuable, they are precious, so we don't find REE as the so-called permission for discharge. Yep.
Okay, thank you, Professor. So let's go to the next question. This is for Dr. Neni. Greetings from Surabaya. Regarding to the biogas during the activation of methane gas, 15 days mentioned in one cycle. How about the daily waste, and how is the activation of the gas? Does it take the same time on the first cycle?
Okay, thank you for the question. Very interesting, but it's maybe it's fit for the batch test. But in our plan, this is already everything continuously. So the waste production is fluctuated from 24 to 30 cubic meter per day. So we just have a ponds for half of the capacity. That's why we have to put more wastewater to the plant. Our plant is a fixed bed reactor using bamboos as a backbed, and we use a multi-step process. So that's why we use that, because we know that the situation is fluctuated every day, and we need some buffering. So the first reactor will be as a buffer tank, but actually the first reactor showed a good performance as a methanogenic too. So it can produce 40% to 60% of the biogas already in the first step. And we have 5 steps following the first step. Actually, this is that is too big. From the capacity is still under capacity, but we plan it because the tofu makers want to increase their tofu production, and especially in the holidays, for example, they produce until 3 times than the normal. So that's why. So everything to make the process simpler. And the retention time, so when the questioners ask about 15 days, our plan per reactor is just only half days retention time. So this is that's why I told you this is a high performance reactor. Yeah, thank you.
Okay, thank you, Dr. Neni, for your answer. So because the Q&A time is limited, so I may just ask one more question to Professor Liu, and maybe we can continue to have the discussion in the column chat column. Okay. So I have a question to Professor Liu. What is your opinion on the current regulation for this recycling concept, and what do all stakeholders need to do to make the triple helix concept really work? Thank you. Yes, please.
Oh, this is a big question, and I will only say that you need everyone's effort to come up with a holistic approach to ensure sustainable utilization of IEEs. Thank you.
Okay, thank you very much, Professor Liu. And I think thank you very much to Dr. Neni as well for the very nice presentation. Now we know that we can use many ways as a source of the circular economy for the REE, for the valuable metals, and also for the biogas energy and microalgae. That is very important for some high technology as well. So yeah. Let me close this session first and hand it out to the MC back. Thank you very much.
Thank you.
Thank you very much, Professor Gissi Liu and Dr. Neni, for the very fruitful discussion with the audience here. Also, thank you, Dr. Jenny Lee. Hence, before we continue to the next agenda, there will be photo session, and for all of the participants, please switch on your video and give your best smile.
Slide number 1. Slide number 2. Slide number 3. Four. 5. 6. 7.
Okay, thank you. Then, before we start our second session, we would like to introduce STIC and our newest collaboration with BRIN, Collaborative Research Center for Zero Waste and Sustainability. Please enjoy the video.
The center is set up among Taiwan Tech ITS and Vidya Mandala Catholic University, Surabaya. The main goal of the center is to strengthen cooperation on science and technology between Indonesia and Taiwan. And we will focus on recycle and reuse of industrial waste. Targeted compounds include fly ash, burning slag, and spent bleaching aid that are of significant amount and to our common interest. It will also involve 1,400 strong alumni in Indonesia, and we will engage private sectors, NPOs, and research institutes.
Through this international collaboration, Institute Teknologi 10 November could strengthen the collaboration between National Taiwan University of Science and Technology, Vidya Mandala Catholic University, and Indonesian Institute of Science. This research center was developed as a platform to connect the researchers from different universities, from ITS, Vidya Mandala, LIPI, and NTUST, with the experts from industry that work together to have the research regarding to the eco-green solution and for the circular economy and sustainability. Waste utilization is one of the implementation of eco-green solution, and we know that Indonesia could be developed this model to recover of the waste and use as a many different purpose, and also we can develop a good impact to the environment and also to the society.
We are proud that ITS, Institut Teknologi 10 November, Surabaya, Indonesia, has been a part of this prestigious international collaboration. The topic of circular economy and green innovative resource matches with the ITS vision and the world focus. So I believe that the research center opens opportunities for researchers to expand the outcome, the connection, and also the international collaborations. In addition, it boosts the ITS contributions to the nation.
Besides a medium to do international research collaboration, this research center wants to provide a database experts from Indonesia and Taiwan so they can find a sparring partner to work together for international research collaboration. By this research center, we do hope that the spirit of doing research and innovation for Indonesian academia can grow and we can have a broader link for collaboration in international scale. And when a new researcher come up, they can use this platform to build collaboration for their research and also support their career. It is a great pleasure that scientists and engineers from Indonesia has a place to work together to build a collaboration with other countries, especially Taiwan. This is a proof that Indonesian researchers can work together and compete with others in the world-class research. Lembaga Ilmu Pengetahuan Indonesia, or we call LIPI, support the research center, and together we can solve industrial problems, especially for waste treatment and reuse. Through Taiwan Indonesia Research Center, we can build triple helix research by connecting government, university, and industry.
As a rector of Vidya Mandala Surabaya Catholic University, it is my great honor to be part of Taiwan Indonesia Research Center to promote international collaboration in order to develop the innovative ideas from Indonesian academia for Indonesia circular economy.
Indonesia needs intensive construction as a modern and developed country. And we know that the source of waste, especially from industrial waste, is abundant in Indonesia. We can use this waste for utilization, and also this is a small step that we can use as an eco-green solution. For example, we have produced a lot of furnace slugs that can be used as a cement additive and also for construction. We also produce a lot of spent bleaching earth that can be used for cement making and also for the absorbent.
We already structured STIC roadmap based on our goal, which is circular economy and green innovative resource. Establish a platform for the collaboration of industry, academia, government administrator. And it followed by a data bank of experts to support potential collaboration and capacity building in the second year. And in the third year, we focused on expanding this collaboration as well as capacity building through seminar, workshop, and exhibition. STIC Saiger also cooperate with Minister of Science and Technology Taiwan and Taipei Economic and Trade Office as Taiwan representative in Indonesia who fully support this center. The Science and Technology Innovation Center raised two main issues, namely circular economy and green innovative resource. The goal of this center to strengthen the cooperation on science and technology in line with new southbound policy of Taiwan government.
Be better together. Together, be greener. Thank you.
Kansa.
And now we will start our second session, and I would like to invite Bapak Kasman as the representative from PT Riau Andalan Pulp and Paper, Bapak Rifan Masyuri as the representative from PT Lautan Luas, and also Dr. Jenny Lee as the moderator for this second session. This session included presentation for both speakers for 20 minutes each, and then discussion with the audience for 15 minutes. For Dr. Jenny Lee, the time is yours.
Okay, thank you very much, Kansa. So in this section, we will listen to the presentation from the industrial experts. Another point of view with the first section, and the first distinguished speaker is Mr. Kasman. He is the head of certification compliance and environment of PT Riau Andalan Pulp and Paper from April Group. Please welcome Mr. Kasman.
Good morning.
Good morning,
everyone. Professor G.C. Liu, Professor Felicia, Dr. Ajeng Arum, Dr. Neni, and Dr. Warma Dewanti, and all honorable speaker, audience, and moderator. Thank you very much for this sessions. Before we go to the main slides, I would like first to share our slides with you. Okay. Is everyone have looked the slide, please? Okay, thank you very much. So it is it is great pleasure to be here with you in this seminar held by Universitas Kristen Widya Mandala, ITS, and TUS. Before going to that main slides, I would like to introduce our company in the few slides. PT Riau Andalan Pulp and Paper actually one of the biggest pulp and paper industry in the world for its single lines. We have 1 million hectare of licensed forest concession, including the Riau ecosystem restoration, and we have a biggest single site pulp mill in the world, produce 2.8 million ton of pulp and 1.1 million of paper, and we support by the R&D science professional, more than 160 people, And of course, we are guided by the responsible forest management policy, both in the forest sites and manufacturing sites, which we call SFMP Policy 2.0. Okay, this is our product, as you see. The flagship name actually Paper Wands. I hope that you have recognized this product in the market, or probably you maybe use it already. If not, yeah, please. So this is a very good quality product, and of course, it is certified by international standard like forest management, sustainable forest management (PEFC) standards. Okay, April has its own policy, which called April 2030 Visions, which is actually it is rooted from SDG, the 17 goals of SDG. In this topic, it is relevant to discuss climate positive and sustainable growth, where we specify, say that we are growing our business through diversification, including here circularity. So we are world-class operations supported by the talent people. And here, some of a key highlight here, our energy are from renewable energy, more than 82%. And then, of course, we treat our wastewater, more than 82%, before discharge to the river. And then we generate our power from more than 60% from black liquor. Black liquor actually is an inherent product of pulp and paper productions. Okay, you see here on energy by source of fuel, and then by power generation, we produce more than 82% our generation from renewable energy, which consists of black liquor itself, and also biomass and sludge. And of course, we also try to look other opportunity like solar energy, which we start already 11 megawatts as in this chart. So total power generates from different source is around 400 megawatts to power our mill. Okay, that's all in our industry. So we believe that industry is important to drive economic and to keep the society sustained. While on other sides, industry, like others organs, like us events, generate amount of waste where if it is not managed well, it will be, of course, it will create a negative impact to the environment itself. So, however, there is an opportunity also in waste. If we change the way we look the waste as a new resources, actually a lot of advantage that and also benefit that a company can obtain from that. So in the next few slides, you will enjoy how April or PT RPP has proven that circular economy as a great business model to benefit the company itself and the environments. Let's go to the next slides. So actually, this is the process, the flow process of pulp and paper production. Here in April or PT RPP, we plant the tree. We call it production tree, industrial plantation. So we take to the mill. First process is barking and chipping, and then you will go to the cooking process with some chemical here you can see, yeah. And after that, it will go to that washings, and then oxygen delignification for whitening, and bleachings for final product. Pulp go to the pulp machines, and then to the papers and go to the customer. This is actually a simple process of how we produce pulp and paper. But at the same time, of course, there is in each step of this process, it generates some waste. For example, in bulking and chipping, of course, we have a bark, which is also, it is a source of energy that we can burn in our boiler. And in the digester itself, we will generate high amounts of black liquor, and we can also burns in recovery boiler to generate energy. But in this topic, we will discuss with you on the strongest initiative we have that maybe can inspire others, industry or academics or governments after discussing with us. So we would like to talk about how the waste from effluent treatment, where we generate a sludge, amount of sludge, that it is also high energy that can be burned in boiler to generate a power. And then from power itself, we generate a fly ash and bottom ash that can be used in others internal infrastructure in our complex. Let's see the first slide. So like others common boilers, we are having a circulated fluidized boiler, we call it. It is a major type of boiler. We can use multi-fuel here, including a low-grade fuel like the sludge, mixed with the coal, other biomass, and then burns in our boiler. And of course, by burning this, we will generate some power. And then what interesting fact here, we emit some emission, but also we emit a solid waste, and then this solid waste will be utilized later. So from this burning of biomass or sludge itself, we can substitute the coal around 80,203 tons a year. So from this also, we can prevent the greenhouse gases emission to the atmosphere around 230,000 ton CO2 equivalent a year. So of course, this is we have to follow some technical requirements that's prescribed in environment regulation. In this particular is Ministry of Environment and Forestry Regulations number 6/2021, and then number 15/2019 about emissions. So we have to test some criteria in the waste itself and then in the air emission to make sure that everything is in compliance with the regulations. So program number 2, I will not spend on the detail because we have some program to share with you. So as we know that in constructions of roads, there is normally a common structure of the roads. It starts from subgrade here, subbase, base, and surface. So we are following that structures. And then we see the opportunity in the subgrades. Instead of filling with the fresh soil, we have the resources, what we call it fly ash, bottom ash, and then we do the research, how to look the best composition, and then we found out that 50% of clay and 50% of fly ash and bottom ash mixed with the, of course, clay, and then we put in the subgrades layers. It's around 2 meters. So then we go to the next level, put a subgrade course compacting, and then we do the testing, required testing that we can show in the next slides. And after that, of course, from the sub-base course, we put some surface like gravel material is an optional. Also, you can change either a concrete or just a gravel in the surface. From here, from this initiative, we can conserve a fresh soil, not taking from the earth, around 3,000 ton soil a year. And this is the specification of general requirements prescribed in General Work Ministry guidance regulation for construction and bridge that we have to follow. And also, of course, on hazardous, we have to follow the Ministry of Environment and Forestry regulation number 6.2021 on the hazardous waste criteria. We have to test some parameters with these limits. For example, on total oxide metals, it should be more than 50%. Of course, also in the product itself, we have to test, meaning that the product here actually the mixing of clay and the waste of fly ash and bottom ash. We have to pass the test of CBR, should be more than 6%, and of course the other criteria like a Proctor test, which has to be more than 95%, and we have to do it in a frequency that has been described in the regulation. Next. Beside these two projects, actually, we would like also to share with you it is a new initiative actually. Besides, we have also pulp and paper industry. We have also rayon, where this rayon also have a wastewater, and then from the wastewater also generates some amount of sludge. In this initiative, because we know that from rayons itself there are 3 streams: zinc, slins, acids, and the zinc stream, we produce zinc sludge, and then in this project we take the zinc and then we mix with the fly ash and bottom ash with the composition 25% zinc sludge and 75% of fly ash and bottom ash. So this is the process flow actually. After mixing, it's going through the disc granulators and then going to the rotary dryer for drying the material, and then go to the rotary cooler for forming, and then there is a screening also here for this doesn't meet the spec, and final product will go to the packaging machines, and then we produce around 200 to 3,000 bags an hour. So the wage is for each bags is 10 kg and 20 kg is how to make it easy to take to the field, and then put as fertilizer in our plantation tree. So this is the other initiative that we also introduced this year. This is actually a new project for us. So what we have followed in the technical aspect, actually, of course, in the hazardous waste itself, in the material, we make sure that every parameter is meeting before processing into the products. And for the non-hazardous waste, fly ash, we have also to test some parameter like a heavy metal here and others parameter, and also including the groundwaters and soil where we put the final product. We have to make sure that it is not affect the environments, and of course, and the quality of the product, we have to make it equal with the market quality. It is safe to the environment. It meet the requirements of the fertilizer, actually, OSNI. So this is the regulation that we follow from Ministry of Environment and also from Ministry of Agriculture 209/2018 on minimum technical requirements for inorganic fertilizer. So this is our third program, Waste to Value, and beside of the program of utilization of the waste that we generate, we are having also a program how to reduce the waste from the upstream level, not become a waste. So actually, this is a straightforward. Actually, we don't have our own technology, so we purchase from outside vendor. Unfortunately, it is not in Indonesia currently or in Asia. We buy it from Europe. It call it fund separator. Actually, FAN is capital. We put it in a pipe before going to the effluents in pulp machine and in paper machine. So we save some fiber which supposed to go to the effluent, but we take it first, and then we can sell out to produce low grade paper by other industry. So this is actually not straightforward for utilization of waste or reduction of waste program, but it is an interesting fact also that in our landfill, which we call is a dead space before, it's just like an empty space, we cannot reuse. However, we see the potential of a great solar power, and we try to prepare a proposal how we can put a solar panel on the top of captive landfill without affecting the membrane, without affecting the layer of the landfill, since underneath the landfill is hazardous waste. So by working together with academic also, thanks also for the research, we found the best foundation that not affecting the membrane inside, which is called a slab foundation, and then while still can support the solar panel. So by having this initiative, also we can reduce the use of coal, of course, because we can produce currently 11 megawatts of power that we can use in our mill, and then it is also can replace the coal. So we reduce against dependency to the earth. So this is actually our initiative on waste to value in April, or PTRIPP, that can be inspire you. As conclusion, so we think that circular economy, waste to value, is the business model that must be adopted by each and every industry to drive the economy, and at the same time to reduce dependency to non-renewable resources. And second is the initiative waste to value will also help the earth, the world, in reducing the greenhouse gases emitted in production process. Of course, like the sample we give, and others, I think we can find out also here how to optimize the waste to value initiative. It requires a collaboration between academics, worlds, private sector, and government itself, as waste to value is not only engineering or machine aspect, but it is also a policy or a regulation that allow us to use these ways, but on others sides, it is safe also to the environment, and it will be governed by the government. And on other sides, academic worlds, of course, do some research on others ways that maybe today cannot be reused, but by the research or by having the others benchmark, we can collaborate, we can elaborate more and put into practice. So I think that's all from us, from me, as a sharing today. Thank you very much for your attentions. I can give it back to our moderators, and thank you very much.
Okay, thank you very much, Mr. Kasman. Very nice presentation from the RAPP. So now let's go to the next presentation given by the distinguished speaker, Mr. Rifan, the Human Capital and Corporate Affairs Senior Manager of PT LNK from Lautan Luas Group. Please welcome Mr. Rifan. The time is yours. Before that, Mr. Kasman, could I ask you to stop share screen first? Okay. And then
let me, okay.
Yes. Okay.
Thank you.
Please, Mr. Rifan, the time is.
Okay, thank you, Bu Jenny. Thank you very much. Good morning, everyone. It's a pleasure for me to hear and share about our sustainability program in our company. So therefore, I would like to thank to head and management of Stitch Cycle, and especially thanks to Widya Mandala Catholic University, Bu Felicia, and also Bu Jenny, because I have great opportunity to introduce our company to all of you. And okay, because I only have 20 minutes, I hope can finish it, my presentation in 20 minutes. So I will doing fast. Let's read my presentation. Can you see my slide, everyone?
Yes, please slideshow.
Okay, I will change to slideshow first. My computer is stuck right now. Difficult to slideshow. I will try again. I'm sorry, everyone.
Is it okay, Parifan? We can also help you to.
Okay, please help me to show our presentation to Jenny.
Okay. Please wait a moment. Okay. Could everyone see the PowerPoint?
Okay. I can see clearly. Okay, thank you, Bu Jenny. Okay, the topic today of my presentation is the impact of healthy product fiber cream towards circular economy. This is based on our practice in our company LNK. Next slide. Okay, I would like to introduce my company first. As Bu Shani mentioned before, that our company PT Lautan Natural Kriberindo is one of subsidiary company of PT Lautan Luas Tbk, and PT Lautan Luas Tbk is domicile in Jakarta, Indonesia, our holding company, and PT Lautan Natural Kriberindo is domicile in Kutorejo, Mojokerto district, East Java. Actually, you can reach from capital city Surabaya within car maybe around 1 hour. Actually, not too far from Surabaya. So every time we cooperation with Via Mandala University, representing Lautan Luas Tbk, we can collaborate and cooperation until today. So very high appreciate with Via Mandala University and also appreciate to our holding company PT Lautan Luas Tbk. Yes, this is our company PT Lautan Natural Kriberindo, as one of subsidiary company PT Lautan Luas Tbk, with the vision to be a world-class ingredient company which focuses on creating value for customers, shareholders. We aim to deliver high-quality food ingredient and provide manufacturing solution to our customer to achieve business enhancement. And main purpose of our company is creating value for customer. We also have a 4 mission. And the mission number 4 is participate as green company that serve only eco-friendly product. This is relevant with our topic today. Next slide. LNK also have a core value, and we can call value our value with creates. That letter of creates is take from the first word of our value. There is 7 value. Number 1 is creativity. We pay attention to and respect creativity. Number 2 is respect. We treat every people or every individual with the utmost respect. There is no harassment, there is no discrimination, there is no racism in the workplace. And number 3 is ethic. We adhere to high ethical standard. Accountability. We responsible and accountable to our roles and will do our best. Teamwork, we work together as team to achieve common goal. Environment, we protect the environment for our next generation. And also the last one is serving. We provide our customer with the best service we have. This is how we do our business, and I hope this value become our culture in LNK and easy to remember that our culture is creates. Next slide. This is LNK milestones. PT Lautan Natural Kriberindo was established in 2010, and in 2012 initialing commercial production and non-dairy creamer. In 2013 implementing ISO 9000 and 2000 and implementing ERP. In 2016 LNK launched a signature product with name Fiber Cream. This is our healthy product, and so on. You can visit my homepage in https://lautan/natural/kriberindo.com. Next slide. This is our green industry concept for implementing in our LNK. We are responsible in energy consumption, using only electricity and natural gas for our protection. And also our packaging paper bag is from recycled paper. Also conduct research and development to create innovative healthy product, perform production efficiency by applying digital transformation industry 4.0. It is a part of our contribution to SDG number 12. And consumption and production responsibility, using cutting-edge technology that are more environmentally friendly, and also regarding with the waste, reject or not good finished product, and dust is collected to forfeit and manage our waste in according to the 4R principle: reduce, reuse, recycle, and recovery. This is our green industry concept implementing in our company. Next slide. Okay, this is a Sustainability Trilema program at LNK. This is a mandatory from our holding company that our all subsidiary companies should implementing sustainability program, and there is 3 programs should be considering in each subsidiary. Number 1 is energy security. We support transition to low carbon economy and continuously reduce to reliance on the fossil fuel based energy. In the product excellence, provide sustainable and excellent product to customers. And in environment, strive to protect and conserve the environment in our operation and decision making in line with our commitment for continuous improvement of environmental performance. This is a trilemma, we can call it, and this is a mandatory from our holding company that all subsidiaries should implement this program. Next slide. This is just information about our production process. We have 2 kinds of production process. The first one is spray drying process, and the second one is dry blending process. Spray drying process using European technology. Our spray drying facility allow our customer to transform liquid with desirable properties into a more convenient powder form. And in dry blending process, facility has capability to produce a wide range of ingredient, blend, and premix. This is our production process in our company. Next. We believe that if we make the product as consumer need, then we make sure that our business is sustainable. This is a product insight from customer view based on survey from the expert that today consumer view wellness across 6 dimensions, and we give contribution to the from the 6 dimension is better health and better nutrition. Next. It is our signature product, fiber cream, to support health and nutrition. And the picture is our product, fiber cream. Fiber cream is a multi-purpose, low in sugar and high in fiber powder creamer that can be used as a creamer as well as dairy alternative and coconut milk substitute. As we know that the diabetes and cardiovascular disease are among the top 2 diseases that contributed to the fatality rate in the country. So we would like to contribute with the produce fiber cream to support health and nutrition for the society. Next. Why the fiber cream as healthy product? I would like to inform that our product fiber cream is low glycemic index and also multi-purpose, as I mentioned before, and also creamy and delicious taste, and contain gluten-free and also lactose-free and low sugar content, and contain high dietary fiber from oligosaccharide or 30% dietary fiber. We proud that our technology process of fiber cream already registered in Indonesia and USA Patent Office. In the left side is certificate granted from our Indonesia Patent Office, and the right side is certificate granted from USA Patent Office. So we proud of our technology process of fiber cream, recognized in nationally and also internationally. Next, regarding with the circular economy, from our healthy product, we have a marketing program. We call it the Incredible Moms program. This is related with empowering entrepreneurship program. Incredible Mom program is a marketing activity in a collaboration with the local communities of ladies, housewives, and moms. And for the program, the company educate the mother and assist them as they introduce and promote fiber cream as healthy ingredient to other mothers, and they will earn incentive for successfully doing so. The IMA project help improve the economy of the family when the mom join. It really helped their economic situation, especially during the pandemic. as they will earn some incentive from their effort of introducing fiber cream product to other moms. The below picture is how mechanism the mom or ladies or housewife can join with this program, starting from recruitment, training and development, and also conduct or carry out the IME program and the reward system. Next. This is also our others program related with the saving energy program. As we know that our company, the main source of energy for the production process is natural gas. This is also low emission compared with the other resource energy. And regarding with the SDG number 12, responsibility in consumption and production, we have implementing digital transformation, implementing Internet of Things, and applying machine learning to control our equipment, especially in burner machine. So we can increase efficiency of burner machine, reduce inefficient running operation. And in 2021, we achieved 40% cost reduction came from an efficient operation of burner machine. In this year, we also initiate to use solar panel to replace electricity. And in this month, next month, targeted start commissioning, we already make agreement with our supplier, PT Touch Indonesia, and hope this can help us to this project. And by using solar panel, target reduce cost estimate 20% compared to on-grid electricity, and targeted can produce electric power 750,000 kWh per year. Also, the other green industry program in our company is using eco-friendly equipment. This is an example that we use our transportation in our company for loading and unloading process in our company using all transportation unit, including our counterbalance forklift, VNA, vehicle narrow axle, are 100% using electric batteries. There is no emission come out from this operation. And also only one waste came out from this operation is used batteries, but we already have agreement with the supplier. When they replace with the new one of the battery, they will bring again our used battery and to recycling. Next. The other equipment is we operating absorption chiller. This is also our green eco-friendly equipment. Another significant difference with a conventional chiller is the absence of refrigerant. An absorbent cooling machine run on a mixture of water and lithium bromide. Lithium bromide is in daily basis we call with the salt or garam. There is no harmful material released to our atmosphere or our environment. So this is a very eco-friendly and also consume far less electricity and therefore can saving in primary energy consumption and carbon emission. This is to our equipment, for example, that our support to green industry. Next. Okay, still related with our consumption and production responsible, we implementing Industry 4.0 to increase efficiency and productivity in our operation. In product quality, we implementing automation, machine learning, and cloud computing, and we can reduce non-conformity product because we have a digital platform, One Plan, the name of our digital platform, that can provide batching report, auto log sheet, parameter analyzer, and also LIMS. LIMS is a laboratorium information management system to detect defect product earlier by data trend. In regarding production cost, especially in the raw material, we implement automation and machine learning, and we achieve increased effectiveness closing liquid material on mixing process. In energy, as I mentioned before, then can reduce ineffective natural gas consumption. In maintenance cost and inventory spare part cost, we implementing Internet of Things and machine learning. We can reduce inventory day of spare part and maintenance cost by apply CMMS, computerized management maintenance system, and predictive maintenance with one plan system. In sales expansions and also in quality of delivery, we also implementing digital transformation by use fiber support application and also AI to optimize sales and marketing activity and so on. Next. This is an impact summary of implementing Industry 4.0 in our company. In smart production, we increase 30% of accuracy dosing, decrease 70% product defect. In smart maintenance, increase 20% production capacity, and decrease 81% machinery breakdown. In predictive maintenance, increase 2% availability of operation, and decrease 33% maintenance cost. In energy management system, we decrease 14% energy consumption ratio. And in digital sales application, increase 40% of number of sales, and increase 43% sales of number of sales, and decrease 11% sales expense. Next. This is our circular economy at LNK. It is our waste. There is a treatment, wastewater treatment, and planting substrate and composting and others. Next. Yeah, the other program is a saving water consumption program. Unfortunately, main source of water consumption in LNK is coming from groundwater. So therefore, LNK shall have a program to return to ground again all of the water reject from RO unit and also water from effluent, waste water treatment, and using to the other utilizing like water of plants and flushing the toilet and so on. LNK also made the reservoir wells to collect RO reject water and rainwater. Assisting, we have 4 units of reservoir wells and will be added 2 units more in this year. And also LNK also utilizing reject RO for employee drinking water using water purifier unit like in the picture. And it is can replace gallon water and can reduce cost on about 10%. The other program is a entrepreneurship program for the community around the company. LNK conduct empowerment activity for housewife around the company to run small business, different with our marketing program Incredible Mom. This is target is our family or housewife surrounding our factory, and it is a CSR program. LNK untuk our company provide assistance with a number of selling charts to housewife as one of a CSR program. LNK also provide training to them on how to cook with various recipes and types of food and beverage that use fiber cream, our signature product, healthy products. And with this program, it's hope that they can become entrepreneur and at the same time be able to sell and introduce our signature product as healthy product to the society. The other program is Youth Community Empowerment Program. This is our CSR program. We call youth community usually with the Karang Taruna. LNK give them wooden waste pallet from used pallet to be processed into various kind of furniture and give them funding facility to up their skill as good carpenters. And LNK also take advantage of their work by buying it back in the form of furniture, in the form of chair, ornament, also food chart that we can give to the housewife to run small business as our CSR program. The picture is our field community around our company, and the produce of their workshop, chair, and on those also chartwoods. Next. Other program is waste management in our company. In LNK, domestic waste is separated based on organic and inorganic waste. Organic waste will be collected and sent to the composter to become compost. In this case, LNK cooperate with the Department of the Environment of Mojokerto, and especially for paper bag waste sold to buyer for recycling, and non-organic waste such as plastic, iron, and metal waste will be collected and sold to waste bank for recycling, and for hazardous waste is collected in temporary storage area and then sent to the company that have license from government to process it. Next. The other waste management program, and this is still our homework to solve this problem. As we know that the final waste program, the final waste from the waste treatment process in LNK is sludge. Actually, our sludge does not contain material that harmful to the environment. Therefore, LNK tried to reuse the sludge as a planting media of substrate. We conducted research and experiment cooperation with our internship student program in our company to conduct research about this and providing certain mixed ingredient to ensure that sludge can be used as planting media. The result of processing sludge into planting media given to farmer around the company. But the output is almost 500 kg per day, but we can process still only 100 kg per day. So still many sludge that cannot be processed to be a substrate or planting media. The other program is environmental conservation program by planting trees on non-productive land in surrounding company. This program is one of our efforts to reduce climate change by reducing CO2 in our environment. Last year, LNK planted 300 mango trees in Pesanggrahan Village, Mojokerto, near with our company. And this year, we have the same program. We will plant 300 mango again in the other area surrounding our company. Next. This is the award received by PT LNK. Award from the best productive company from each governor. Zero accident award from Labor Ministry, and proper environment from Ministry of Environment, and the award regarding implementation technology of industry from Industrial Ministry, and award from regarding transformation industry 4.0 from Industrial Ministry, and others award that we cannot put here one by one. Okay, thank you very much. We hope in the future we can collaboration with STACI regarding waste treatment in our company, especially how to reuse our sludge, because we still have the homework to solve this problem in our company. Thank you for your attention. Thank you very much, and giving back to the Bu Jenny as moderator.
Okay, thank you very much for the very nice presentation, Pak Rifan. Okay, now we are going to the Q&A session. So, do you have any questions? I think we got one question from Bu Neni. So, this question is to Pak Rifan. Okay, what kind of step that we can do, significant step that we can do or have done before to reduce the energy consumption, and also in the process, in the spray dryer process in LNK.
Okay. Before we implementing in the 4.0, in the burner machine, there is no measurement tools to detect the burner machine when running in inefficient condition. our operation or technician just based on a report of our consumption energy report, bi-weekly or monthly report, and they decided that our burner machine is run in inefficient condition by the information of the gas consumption. And when they see that our consumption gas energy is increased, they starting to do repair our burner machine. For us, this is too late because actually sometimes based on the consumption is they don't know that the burner machine already run in inefficient condition a week or 2 weeks ago. So we lost in energy maybe around 1 week or 2 weeks ago. So with the implementing machine learning, we can detect precisely when the burner machine run in inefficient condition. So our technician or our operator can decide precisely the burner machine should be stopped and do repair to reset efficient again for the burner process. This is the main program in our reduce efficiency consumption.
Okay, thank you very much, Mr. Irfan. So if you have any question and want to ask it, the honorable speakers directly, you can raise your hand, or yeah, maybe you can just put the question in the chat column. Okay, so maybe I also have the, oh, okay, let's have the question. Okay, continuing the previous question, are the LNK using the industrial gas from the government or from the different source? Another source, maybe alternative source, Mr. Irfan?
First, we consume and buy from Gas Negara, PM Gas, but now we currently from different source actually, because the price and the quota is not enough, so we buy from the other source. It's not only
So
from
LNK combining from the government or and also from the private company.
Yes.
For the gas,
Yes.
natural gas. Okay. Okay, so let's move on to the next question regarding the situation. Regarding in the situation, this is the question from Anahi, Taiwan Tech. Regarding the situation of the forestation in the Indonesia, which has mentioned last year in the COP26, does April Group have any project to approach any solution? Yes, please, Pak Kasman.
Okay. Thank you very much to Ibu Anahi on the question on the situation of deforestation in Indonesia. Is April Group have any project to approach or solution for this? It's a great question, and also it's a big question also. April commits to protect the environment and also commit to use the renewable raw material. So since 2015, April has no consumption on natural forest. So 100% of raw material to produce April product coming from renewable plantations. And then what April do on other sides actually to protect the function of the forest. We have voluntary engaged with a very ambitious projects which we call one-on-ones, where 1 hectare of our production, and then to protect a hectare of forest, natural forest. So currently we have around 200,000 hectares of natural forest, which is give the license to April to protect it, which we call it restorasi ekosistem Riau, to restore restorasi ecosystem, to restore the function of the forest. We don't take anything actually from that forest. We just protect it from illegal encroachments, from loss of biodiversity. So we also provide a center for research for the scientists to do the research on, for example, peatlands in that area. So in national scope also, last time we have also give to the governments a natural nursery, breeding natural nursery in Bogor, hand over to the governments, Nampin, if I'm not mistaken. So it's a kind of rising awareness how economic and environment can go hand in hand. At the same time, economic is required to drive the economic, to keep the society sustains. Without driving the economic, how we keep the economic and then keep the society sustains. So, but at the same time, we can still do not to give or to minimize negative impact the environments, like the conservation program or restoration program. Thank you.
Okay, thank you very much, Pak Kasman. So you mean that April already used the
raw material?
The raw material from their own plantation.
Correct, 100% from plantation.
So 200 hectares. Right. Okay. So how long can we produce the pulp and paper from 200 hectares? How long? How many years we can?
Okay. In the beginning of my slides, as introduction to the company, we have even millions hectares of plantation, which divide into 3: our own concessions, long times joint venture, and also from open markets. So that's already established plantation. How long it takes from nursery to wood that ready to convert to pulp? It takes only 5 years. So this is the advantage of Indonesia as a four weather season, right? So all the weather in Indonesia is summer, so it's a good climate, it's a good ecosystem to grow the tree, a planted tree like acacia, also eucalyptus, which is good to produce pulp and paper. Yeah, it takes 5 years. 5 years is compared to other country like subtropical country in Europe, other part of the world, Canada, for example. It will take maybe 25 or 30 years if planned today. and then it is not so economic in terms of profits
Okay.
or efficiency.
Okay, thank you very much, Mr. Kasman.
Yeah.
So maybe due to the time limits, so maybe this is the last question that I would like to ask to Mr. Ivan and Mr. Kasman. What is the big challenge that RAPP or LNK encountered to contribute to the circular economy or SDG goals in the Indonesia? Maybe from Mr. Kasman first.
Okay, thank you very much, Prof. Jenny. So the big challenge actually is on research actually. So we need a research that readily easy to turn to practice actually. So considering the huge amount of waste, and like April do, we have for example around 1,200 ton solid waste generated every day. So how this solid waste can be easily utilized and then still meeting the requirements. So we see a lot of opportunity actually, how government project, for example, in Riau province, the government would like to construct a toll route, for example, how private sector can participate, like using our fly ash as a subgrade, for example, or hardening the road condition before it's contract to toll, which is it is high absorption, and also sustain, continue, because we generate every day. And then we need a certain planes bought from not only our internal utilization, but also from external use. So it can be aligned with the company strategic also. For example, when we commit to supply our solid waste, because we consider it is not a waste, it is a resources. So it will also change our scenario. For example, we are not going to construct any more landfill, but at the same time, when there is no demand, when there is no need for this, of course, it will affect our operation. We will end up with landfill and then end up with no place to put this waste. So that's the challenge. So let us now see the waste as a pill, as a permata.
Yes.
A waste is only fiction.
Yes.
Waste is only fiction. A waste is not real. It is money. It is huge money actually. So let's focus on that. All energy put in there, how to, from the government side, how to generate more regulation, which based of course on the science from the academics, and then give opportunity in a very open spectrum how to use this waste. So that's what we expect also from private sector.
Okay, thank you very much, Mr. Kasman. How about from Mr. Ivan?
Yes, the big challenge for us is when we implementing the circular economy is a support from the government actually. This is a big challenge because when we would like to for example, would like to reuse our effluent water from our wastewater treatment, there is some permit that we have to fulfill, and there is no easy to get the permit from the government. We have to make some paper like a presentation to them, and not too easy to get the permission actually. But our wastewater treatment is already run improperly and fulfill the regulation. All parameters we comply with our parameter, and effluent water is better for environment. There is no harmful chemical again related to our environment. For example, the other thing is when we would like to implementing solar panel, not easy to get permit from our PLN. It's very difficult to get a permit from them. This is a need of support from the government. This is our big challenge when we implementing our circular economy program in our company. That's all my opinion. Thanks, Kuchen.
Okay, thank you very much, Mr. Ivan and Mr. Kasman. So the development of the waste utilization should be more and more, and also supporting by the regulation from the government. It is very important. We all hope that the government can see another point of view that waste is a resource right now, not anymore damaging or pollutant before discharging, because we can treat it as the new research, green innovation, and circular economy as the goal of STIC. Okay, so that's all from the section 2. Thank you very much for the honorable speakers, Mr. Ivan and Mr. Kasman. It's very impressive presentation from two of you. So let me hand in back to the MC. Thank you very much.
Thank you.
Thank you. Thank you very much for the very insightful session. We understand that in order to achieve the sustainable development goals, we must be able to deal with the changes that are occurring in our environment. So from presentation by Professor Giselle Liu, we learned about most recent research and findings regarding sustainable utilization of REE, as well as recommendations for improving such sustainability. From Dr. Neni, we also get to know the current research and finding in BRIN regarding potential of tofu waste as new raw material source to support sustainable economy. From Bapak Kasman, we learned how to make waste become valuable material, and from Bapak Rifan, we understand the role of industry toward waste management and circular economy. Since we have reached the end of today's event, I would like to sincerely apologize for any mistakes I may have made in presenting as Masters of Ceremony. Thank you for participating our event. See you and happy and nice day.
Thank you, Bu Jenny, Bu Felis. See you.
Thank you very much for all the honorable speakers.
Yep.
See you.
See you, Bu Jenny.